Hello everyone. So now let's talk about thread in process management. First of all, what is the definition of process? That is program under execution or program which is running at a time. Okay, and whenever program is executing, whenever it is in running state, we call it as a process. And whenever there exists some process, there are address space related to that particular process, global variables, register, stack. These all are the plus additionally some resources which is currently used by that particular process. So now comes the question of thread. What is thread? Okay, so let's see first of all definition. It is a lightweight process created by another process. So it is nothing but a process itself, but it is created by some another process. So what is the difference? But the word over here is lightweight process. Okay, so that is the all, or I can say that is the that is very important word that differentiate thread from the process. Now over here you can see this circle represent process. Okay, and with time this process can create a multiple threads. Now what is the function of thread or whatever, how it is different from process, how it is similar to process? Okay, we will discuss all these things in this video. So first of all, let me give you an example. Okay, I am dealing with my text in Microsoft Word. Okay, so whenever I am dealing with this over here, if you can observe, Word is saving programming with parallel. That means it is saving this file. Okay, whenever user is actually writing over here, you can many times you have noted that if you don't save particular file within some time limit, this document, it should be auto saved. Okay, it is actual scenario like that. So so over here this word processing is actually whole process. Okay, but this process has created many thread. For example, one thread, it can be interacting with user. This is another thread which is dealing with auto saving of your document file. Okay, it may be possible that there is third thread which is performing tasks related to formatting of this particular text. Okay, it can be possible that there is another thread which is dealing with this printing of this document at extra. So you can see whenever you think that you are performing this single process, but actually inside this process there are multiple threads are running over there. Okay, and they are performing this this task. Whenever we call process is a very light process. Is not a lightweight process, it is a heavyweight process. Okay, why heavyweight? For example, if you are running C program, okay, then running of C program involve many tasks. For example, compiling of program. Okay, and whenever you compile in build, there are various things that happens over there. Okay, so that task is divided by that particular process. Okay, and that task, this divided task is performed by this thread. So thread is lightweight process. They are not actually doing all the task, but they are performing part of particular task. Okay, which is process itself. So processes are used to execute a large, that means a heavyweight job, such as working in Word. Okay, while thread are used to carry out smaller or a lightweight job such as auto saving Word document. So thread is a lightweight process created by a process. Thread is a single sequence stream within a process. Now process itself, one process is totally individual to another. Okay, but in process all the threads are connected. Okay, thread has its own program counter, own system registers and stack. That for example, if program counter, that keeps track of which instruction to execute next in particular thread. System registers which hold its current working variable. Now if I say process create another process, but they are lightweight process, okay, and we refer it as a thread. This is not a child process, it is a different thing, okay. How it is different, we will see it later, probably in this video. So it is not a child process, it is a lightweight thread, okay, lightweight process, we call it as a thread. Now task of thread is to perform a small part of that particular process. So it may be possible they require variables which are currently stored in registers, okay, data, it might require data. It is, or they are also using stack, okay, and it contain the execution history. Now let's see example. So over here, these are the, let's say, pages of some book, okay. Let's assume there are total 600 to 700 pages over here, and I am writing one book, and this is my system, and this is referring to process which is created while I am writing my book in Word document, let's say, okay. So this is keyboard through which I am interacting, or I am typing like that, and this is the disk in which I want to store my this document text, okay. So this process creates thread, multiple thread as per its requirement. For example, this thread I have created, task of this thread is to interaction with the user, okay. So task of this particular thread is to interact with the user and collect whatever the user is typing, okay. And after that, this is actually it is a third thread which is referring to the task of auto saving, okay. Now we call, if auto saving, that means this file is being saved in disk, in a hard disk, okay. So this is the third thread, and the middle one, that is the second thread. Task of this thread is to formatting the text in this particular pages. So if let's assume there is no concept of a thread, then what will happen? Let's say I have written 600 pages, okay, and I need to change some text in page number 1, and then I require to jump to the page number 600. So what will happen? I have changed, or I have deleted some lines from page number 1. From page number, if I delete some lines from page number 1, and then I need to move to page number 600, sorry. So once I delete some text in line number 1, then first I have to process all the pages before going to page number 600. Why? Because until I do not process all the pages, then I will not get idea of that means system, okay. Then system will not get idea of what will be the first line of page number 600. Because why? Because once you have deleted some text, that means that space is removed and your text is just shifted back, okay. That's why you need to first save all the pages after processing, and then only you can jump to that. So it may be possible that this process is delayed, okay, if there is no concept of thread. But if there is a concept of thread, then it might be possible that whenever user is scrolling down the page, okay, whenever user is scrolling down the page, so this is the interactive, this task of this particular thread, that is interactive, okay. And in the background, this second thread is performing all the tasks related to formatting. So it is performing formatting, that means deletion or addition something, okay. And this particular thread, third one, is updating all the, that means saving all the pages. So there and in that situation there will be less time lapse, okay. And you can process your process can be executed with minimal time. So that is the concept of thread, okay. So this example is just for your convenient to understand the concept. Now let's see in which terms process has how many items and thread has. Okay, so process has its own address space, global variable, open files, child process, pending alarms, after that a signal handlers, accounting information like how many time has been how many CPU allocation has been executed for this particular process. Okay, what is range of address space, what are the variables used by this particular process, what are the files that is being used by this particular process, how many child process are created by this process. So this all the things is related to particular process. But when we talk about thread only counts to the program counter, registers, stack. That means each individual thread has its own program counter, register and stack. Okay, but thread, if one process has a 3 thread, okay, then you can see that process has its address space, it has its global variable, open files, okay, child processes. So if I create a 3 processes, does it means that this all 3 threads has a separate address space? No, the answer is no, and that is why this thread is known as a lightweight process. Now let's okay, there is also state. Okay, thread can be in any state, for example running, blocked or ready state. Now just see this concept. You can see this is a single process with single thread. That means it is a single process. Okay, that you are just till now whatever you are understood about the process. So it can have register, counter, stack, data and files, and this is code. That means it's address space. Okay, but once multi-threading concept is introduced in processing, so you can see there are total 3 threads. Okay, first, second and third, and they all are sharing code. That means it's address space. Okay, they all are sharing this data and files. That means it's IO resources, but they all have their own register, counter and stack. They all have their own register, counter and stack. Now you can see these 3 threads are of a single process, and it might be possible that this thread wants to communicate with this thread. Okay, so it is requirement that all these 3 thread share this address space. Now let's see similarities between the process and thread. Like processes, thread share CPU, and only one thread is running at a time, just like the process. If I say multi-programming, that means multiple processes are there, but actually CPU is running single thread at a time. So same goes with thread also. Like processes, thread within the process execute sequentially. Okay, so order is maintained over here also using various scheduling policy, which there are various scheduling policies related to processes. So same is applicable to this thread also. Like processes, thread can create child thread also. Okay, like a traditional process, a thread can be in any one of several states. For example, it can be a running, ready, terminated or a blocked. Like a process, thread can have a program counter, stack, registers and state. So this is the similarities between process and thread. Now let's discuss about these similarities. Unlike processes, thread are not independent of one another. Okay, I have just mentioned that point in previous example of comparison. There are 2 images. Okay, one with single thread and the another one is 3 thread. So if 3 thread are sharing same address span, then obviously they are not independent, they are sharing. Okay, so they are not independent, and of course they all are of single process, while process can be it can be of separate users. Okay, thread within the same process share an address space, just I have explained. Unlike the processes, all the thread can access every address in the task. If there are 3 processes, okay, then they cannot share or they cannot access address space of remaining process. But if I talk about thread, for example, in one process there are total 5 thread, okay, then all 5 thread can access every address in the task. Unlike the processes, threads are designed to assist one another. Not that processes might or might not assist one another, because processes may be originated from different users. That is the reason. Okay. Now let's see advantage of thread. Thread minimize the context switching time. Now, as I have said, thread are only one thread is running at a time. Okay. And the second point is thread can be any state. That means there is also switching of thread within particular process. Okay, and you have seen the if you have seen the video of a context switching, or I can say process switching, you can see there is major portion was it spanned in switching time in which CPU is idle. Okay, but whenever we are executing multiple thread and then there is some requirement of a thread switching, then this switching time is very minimal compared to process switching. Okay, use of threads provide concurrency within the process. Obviously process is divided into threads, and you can execute any thread. That means provide concurrency. Efficient communication, it is more easy to create and context switch threads. Thread can execute in parallel on multiprocessors. With thread, an application can avoid per process overhead. Now, for example, if I create 3 child processes instead of 3 thread, okay, then there will be a lot overhead compared to 3 thread. Why? Because each process has a separate address space, separate registers, separate global variables, stack, data, files, like that. Whenever thread are sharing all these entities, that's why it avoid per process overhead. For example, thread creation, deletion, switching is easier than the process. Okay, threads have full access to address space, so it provide easy sharing. So this is the introduction, or I can say overview, or I can say a theoretical portion of thread. Okay, and next video lecture we will discuss types of thread in operating system. So I hope you enjoyed this video. Bye bye, stay safe.